Hi, in this video, we're going to be talking about how we can show triangles are congruent. Now, what's cool is rather than finding all six pairs of sides and angles for a triangle, we only need three specific parts. And those three specific parts come in one of four different varieties. So side, side, side says that we've got sides, sides, and sides. If you can get to this point where you know all of the sides are congruent between your two triangles, they've got to be congruent. Now, the next one is side angle side. So you get a side and another side, and then you need an angle that's between the two sides. The angle has to be between the sides. Or you can have the reverse. The reverse with angle, side, angle says that you've got a side like before, but then you get angles on either side of it. So you get this one and this one over here. So you've got side between angles. Okay. And then our last variety is angle, angle, side. So you've got two pairs of angles. And then after those two pairs of angles, you get a side. So maybe it is this one over here. So you've got two angles and then a side, two angles and a side. Um, Now keep in mind, this one works, these two don't. These will never work. So this is not a good word. It is also not a good theorem for our geometry. So make sure that these ones aren't ones you're going to use. You're going to use one of these four theorems. So if I'm looking at these two, I want to try to figure out who's going to be congruent by angle, side, angle, and we're going to cross out the third. So if I look at this one, I've got an angle and a side and an angle as I'm kind of moving counterclockwise around, and it works the same way clockwise. Angle, side, angle. So this is a good angle, side, angle triangle. When I look at this one, it is still good for congruent statements, but this one is an angle, angle, side, or a side, angle, angle. Either way, this one is a different thing. We want something like this for angle, side, angle, where we've got an angle, then a side in between it, and then an angle right afterwards, as we're kind of moving clockwise or counterclockwise around the thing. I did those two backwards, but you know what I mean. So this one doesn't work for angle, side angle, but the other two do. So we could say that this triangle is congruent to this triangle. Now we're not going to do proper proofs of these, but we do want to think about, hey, would we be able to say that these two are congruent or these two or these two? When I'm looking at this one, I see I've got a pair of sides. I've got an angle that's right after there, but I need a third piece. Fortunately, we've got another piece right here in the middle that's got to be congruent. We can do that thanks to our reflexive property. If prop. So I've got a side angle side, side angle side. So while it might not have necessarily been marked right away, we can say that those two are congruent. So using side angle side, and since they are congruent, we can write our congruent statement. So I'm going to start with our B, go across our angle that's congruent, and then go to our non-congruent side, or non-marked side. So B congruent A to R. So B, A, R. Start with my marked angle to my congruent side to the unmarked side. R, K, B. To make sure that things match up nicely, make sure you're kind of like following a similar logic. Marked, marked, nothing. Marked, marked, nothing. If I check this next one, I've got a pair of sides that are congruent. I've got another pair of sides that are also congruent. I just need one more side. Well, fortunately, just like the previous example, I can say this side in the middle has got to be congruent according to the reflexive property again. So that's one more pair of sides. So I can go side, side, side. To make my congruent statement, I'm going to go 2, then 6, and then that double marked thing. So RST has got to be congruent to triangle. Again, 2, 6, unmarked. 2, 6, unmarked. RAT. There we go. In this last example, I've got these pair of sides that are congruent. I've got these pair of sides that are congruent. And then what else I could mark is I could say that these angles are congruent thanks to vertical angles. However, once I do that, I'm like, what is this? This is side, side, angle. Oh no, that's one of the ones that we're not able to do. That one doesn't work. So I'm not able to say that they're congruent. I need another piece of this triangle in order to be able to say that they're congruent. I could, if I got maybe these angles up top, there's a few options. If I got B and R, if I knew that angle B was congruent to angle R, then I could use side angle side. If I knew DA was congruent to AW, I could do side, side, side. Oh, and knowing BR are congruent, I could also do angle side angle. I'd have lots of ways to do it if I knew this B and R thing were together. I don't think I could do, oh yeah, angle, angle, side. Just knowing that B and R, that would also get me angle, angle, side. So I'd get lots of things if I just knew B and R were congruent. DA and AW, that also works. And that's it for this video on triangle congruence. Reminder, you're either saying that all three sides are the same, you've got two sides and an angle, two angles and a side, things being in between each other, or two angles and a side where that side is outside of two angles rather than inside the two angles on this one. Remember, these two do not work. They will not give us congruent triangles. Thanks so much for watching. Bye-bye.